Experienced installers develop a form of X-ray vision, the ability to look at an existing wall, ceiling, or floor and know what's inside of it. Now, when visualizing a wall such as this, you need to be able to visualize the most likely framing behind the surface, how to easily route cables through that structure, and to visualize what other services are already in the wall. To help you develop your sense of X-ray vision, the first thing we're going to do on this part of the course is a brief review of how houses are built, focusing on those areas that will affect your installation the most. Now, even if you have experience in new construction, you probably haven't paid much attention to exactly how those houses are built, and it's unlikely you have any exposure to older construction techniques. So let's start with a brief review of framing. In North America, you'll encounter two types of house framing, what's called balloon framing and platform framing. Now, balloon framing was popular in this country from the late 1800s till about the mid-1900s to around World War II. After World War II, platform framing became much more common due to unified building codes and the dwindling supply of quality dimensional lumber. Now, in balloon construction, a board called a sill plate is laid directly on top of the foundation wall. Floor joists are then laid on top of the plate, and exterior wall studs are nailed directly to the joist to create the first floor frame. Now, these wall studs may extend all the way up through the second floor to form the second floor framing as well. Now, the joists for both floors are tied directly into the exterior wall framing as well as any interior wall studs as well. And then wood floor planking is laid on top of the joists and nailed directly to form the remainder of the first floor frame. Now, the whole framing is tied together as it's built, and cross bracing of the floor joists and the wall studs provides the necessary strength. Platform construction gets its name because each floor is built as a platform or deck. Now, the sill plate is laid on top of the foundation wall, and the platform is built with joists covered by a plywood flooring material. Exterior walls are then fabricated as a unit, with the studs connected to a top plate and a 2x4 bottom plate, and the whole thing is tilted into place, and then the bottom plate's nailed directly to the deck. Now, the second story of a platform house is simply a repetition of the first floor, nailed on top. A significant amount of the strength in a platform house actually comes from the exterior wall material. Now, though both systems use studs spaced at 16-inch intervals, you'll find more attention to this 16-inch rule in platform framing rather than in balloon construction. Now, let's start from the bottom up in both house types to show you the details of how they're framed and how to run wires in that framing spaces. Now, the foundation of the house will either be a basement, a raised foundation with a crawl space, or a slab on grade, depending on when and where the house was built. Typical basements are usually 8 feet high, constructed of either concrete blocks or poured-in-place concrete. Now, this obviously makes it a heck of a lot easier when it comes to getting wires up and into the walls. A raised foundation usually lifts the first floor platform about 24 inches off the ground. And again, the foundation is either concrete block or poured-in-place concrete. Like the basement, you've got access to the underside of the first floor, but there's not a lot of room to work in. Now, slab on grade is exactly what it says. It's concrete poured directly on the ground. Not much help to us here. In balloon framing, the wall studs and floor joists are tied directly on top of the foundation wall. There may or may not be a fire block board on the inside of the crawl space of the basement. Now, wood floor planks are nailed on top of the floor joists, and note that these floorboards usually go all the way over to the outside of the wall surface. But because it's very open, this construction makes it easy to get wires up the wall from underneath the house or crawl space. You may have to drill through this fire block board if there is one, but it's still pretty easy. Now, Again, in platform construction, the deck is built on top of the foundation, on top of the sill plate, and the exterior wall is nailed to the deck. Now this makes it a little trickier to get up the wall since you have to go through the flooring material and into the bottom plate of the wall. Now the problem is the plate's always on top of the flooring, so you're not always able to see exactly where to aim. Now the trick is just to keep as close as possible to this rim joist, as it's called. Now that will get you close to the center of the bottom plate. Moving up the wall in balloon framing, the second floor joists are tied into the outside wall studs, just like on the first floor. In many older homes, this makes a completely open, straight shot from the first to second floor. Now, in some construction, you may find a in-wall fire block either located here or here, and the second floor flooring boards will extend out to the wall surface, but in general, it's very easy to get between floors. Now, you'll see examples of this in Part 3. Now, in platform framing, the second floor platform is built right on top of the first floor walls. On all of these load-bearing walls, you'll always find a double 2x4 header on top of the wall. Now, to run between floors means making holes in the top and the bottom plate, staying just inside this outside rim joist. We'll show you how to do this in Part 2. Now, once you've drilled up or down to get into this floor space, it's a clear shot to get across the first floor ceiling for things like in-ceiling speakers. The framing where the exterior wall meets the roof is similar in both construction types. Now, there will always be a double top plate on the exterior wall where it joins with the ceiling joists and the roof rafters. There are two general situations you'll encounter. The end of the roof, where the wall is parallel to the rafters, and where the rafters rest directly on the supporting walls. The easy one is where the wall is parallel with the rafters on the end. Now, it's easy to drill up into the attic or down from the attic into the wall, and there's even usually space to stand up in. Now, then there's the situation where the rafters rest directly on top of the wall plate. Now, this makes it hard to drill down from above because of the real tight quarters in here. But it's fairly easy to drill up into the attic space, but you've got to be very careful. If you go just a little too far, you'll wind up in outer space. The better situation is where the ceiling joists extend out from the exterior wall and the roof rafters are tied onto the ceiling joists. Now, this gives you a lot more room on top of this exterior wall, and it's usually very easy to find these wall plates underneath the attic's insulation. Now, the nice thing about working in older balloon frame houses is that typically large, unobstructed attics, since the roof joists are large, there's more of them, and they don't need as much interior support. Now, platform construction, on the other hand, typically uses roof trusses because they're low cost and easy installation. Now, here you'll usually find adequate crawl space, but it can be a real nuisance and sometimes a hazard to work in. Now, let's look at the framing for doors and windows, the most likely place for security sensor installation. The framing for platform and balloon construction is very similar here as well. Now, the window framing will always have a header above to carry the load to double studs on each side. The header is typically a couple of 2x6s or 2x8s on end. The bottom or sill plate may be one or two 2x4s. Now, you'll always be drilling through the existing window frame either up into the attic, which means you have to drill through the header, or sideways into the adjoining wall cavities, or down into the basement or crawl space. Now, except for very small windows, there will always be what are called cripple studs above and below that you'll have to watch out for. Now, the framing for doors is very similar. There will always be a header above, 2x6s or 8, and one or more cripple studs to watch out for. The exterior wall covering in both construction types is wood sheathing. Now, in the balloon frame house, the sheathing will probably be wooden planks. On top of this are overlapping layers of tar paper and then some final exterior covering. In platform homes, plywood or OSB oriented strand board is going to be the exterior sheathing. Over this, there's going to be a moisture barrier installed, and this is either going to be tar paper, plastics, or some kind of foam board. And then finally, an exterior finish will be applied to complete the outside of the house. We'll come back and talk about the insulation shortly. Now, let's take a look at the interior wall framing. Interior walls can either be load-bearing or non-load-bearing. Now, a load-bearing wall is simply one that's supporting the structure above it, and a non-load-bearing wall isn't. It's just dividing up the space. Now, in balloon framing, the load-bearing wall studs are tied into the floor joist, always over a foundation wall or beam. The nice thing is, this usually creates a nice open space right up the wall, allowing easy access. In platform construction, the interior walls, load-bearing or not, are always built on the platform and may be difficult to find from below or above. Now, even if it's load-bearing, it may not be built over a supporting structure. At the top, a load-bearing wall will have a double top plate with joists resting on top of it, while a non-load-bearing wall will have a single plate and the joists are never resting on the wall for support. Since you'll be making many openings in existing walls, not all of which are planned, it's essential to understand how interior walls are covered. Here, there are big differences between balloon and platform construction. Up until the 1940s, interior walls were covered in what's called lath and plaster. The lath base is a series of rough wooden strips nailed to the studs. Now, these strips run horizontally across the wall, up and across the ceiling. They're spaced about a ½ inch apart. On top of that, there's a heavy coat of plaster which is forced into the cracks of the lath. And on top of that, there's generally 1 or 2 layers of fine plaster. Now, because this was done in layers, though, it can come off in layers, so you have to be kind of careful. In some lath construction, you may also find a layer of wire mesh on top of the lath as well. Just one more challenge in getting through the wall. Now, making a hole in wooden lath can be tricky if you don't know how to approach it. You can cause a lot of damage if you try to use something like a saw. Now, cutting through with a saw will invariably cause these boards to vibrate, causing cracks in the plaster. Now, a routing tool works best here, and we're going to show you how to use it in part 2. By the 1950s, wooden lath was replaced in many areas by a cement wallboard material. This was covered with 1 or 2 layers of plaster, finer plaster coating as well. Now, it still requires care in making holes to prevent cracks, and we'll show you examples of this in our Michigan home in part 3. Drywall, or sheetrock as it's often called, is what you're familiar with today, and as a general rule, is the interior finish you'll typically find on all platform frame houses. It's easy to make holes in this material with a drywall saw or a routing tool. The hassle with installing cable in exterior walls is insulation. The amount of insulation has increased steadily over the recent decades, and homes built since the 1960s will always have insulation. And it seems like almost everything has been tried for insulation, from peanut shells to expanding foams. But let's take a look at the most common types you're likely to encounter. While it's true that houses built prior to the 1950s used little or no insulation, many of these homes have been retrofit with some type of blown-in or loose fill material, anything from rock wool to shredded newspapers. Now, this material settles over time, which could mean that at the top of the wall it's empty and the material could be compacted at the bottom. But in either case, it's very easy to get wires through this material using push rods or stiff fish tapes. But you need to be very careful when working with this kind of material. It can easily contain asbestos or other particles that can irritate your eyes and breathing, so be careful. Now, the most common insulation in platform construction is fiberglass, which was first developed in the 30s, but didn't see widespread use in homes until after World War II. Fiberglass bats, as they're called, are designed to fit right in between the wood wall studs. The bats have a foil and paper surface, which lets them attach directly to the wall studs to hold them in place. Now, bats may be stapled directly to the inside of the stud. If so, this leaves a little space between the insulation and the sheetrock that you can get your wires run. If the insulation is stapled to the outside of the stud, this still will often leave a small gap between the insulation and the sheetrock, and this is a place to run wires as well. Now, attics are also well insulated, and this can be a real nuisance. Here you'll find rolled fiberglass or loose fill or blown-in materials. In older homes, the insulation could be thin and settled over time, so this allows you to see the top of the ceiling joist. But in newer homes, the insulation may be a foot or more thick, making navigation in this area like hiking in a fog. But remember, when working with any of this insulation material, be sure to wear appropriate breathing mask and eye protection, even if you're just up here doing an estimate, because this stuff can be real nasty. While the majority of homes are built with wooden framing, you'll occasionally have to deal with an alternative building system such as concrete block, concrete forms, steel framing, or structural insulated panels. Now, by far the most common, concrete block construction pretty much says it all. Solid walls of concrete block that may also be filled with concrete for extra strength. This definitely rules out running cable inside the wall. But if you're lucky, the inside surface of the wall will be finished with 1 by 2 inch furring strips. These are used to mount panels of drywall. Now, if this is the case, then you can possibly use the cavity between the concrete block and the sheetrock, also shown down here, to run your cable, and we'll show you an example of how we did this in part 3. But it's not uncommon to find a layer of foam insulation between the drywall and the concrete. And in warm climates, the concrete block is just going to be painted or finished and plastered. In either case, your best bet may be use a surface raceway. Surface raceways provide an enclosure to mount cables on the outside surface of walls. Now, they come in various shapes and sizes, both in metal and plastic, to accommodate various quantity and sizes of cables. Now, some of the most convenient raceway to use are these plastic channels made by Carlon. Now, they come in both rectangular and these tapered shapes in both 5 and 10 foot lengths. Now, they're real easy to mount. All you have to do is pop the cover off, install them with screws or the self-adhesive backing, run the cable, and the covers just snap right back on, making a real easy installation. Now, they also make this rather unusual cove-shaped channel as well. Now, this is designed to mount between the ceiling and the wall to look like molding, and when installed, it's almost invisible. You can also mount it between adjacent walls in the corner as well. Now, this small tapered channel can easily accommodate 2 RG6s and 2 Category 5 cables, and the rectangular raceways got plenty of room to handle that, plus additional cables such as these speaker cables. And there's plenty of installation hardware to make your installation look real good, like transitions, right angle bends, inside and outside corners, and they make a variety of these surface mount wall boxes in various depths. These are designed to handle standard outlet hardware. Now, there's also much larger channels available, such as this 4x4, and the only difference is just designed to handle a lot more cables. Now, it comes in various colors as well, mounts the same way, and it has an easy snap-off cover. Now, this thing can be a real problem solver in installations where you have to make your own vertical chase between floors. Now, you can mount this thing in the corner of something like a closet, particularly where there are common walls between floors, to get cables from the attic to basement. This thing is large enough to house all the cables you'll possibly need for a retrofit installation. This is a small but good example of how surface raceway can be used to solve a common problem. In our case, we use the channels to mount an outlet on this outside concrete block wall. We used the channels to bring the cable over from an adjacent wall where we could get our wires down either from above or from below. Now, I cut a small piece of the raceway cover back so you can see how we made a hole into the channel, which allowed us to bring the cables from inside of the wall directly into the channel. Now, this makes a really easy and neat installation. Steel framing is a retooling of wood frame construction, with steel replacing wood in all framing elements. You'll typically only find steel framing in homes built within the last 10 years. A major consideration in working with steel framing is to keep from cutting wires on the sharp edges. Now that you know how the house is most likely to be constructed, you need to understand where other services are located. Now, part of your X-ray vision skill is the ability to anticipate where other services such as ductwork, electrical, and plumbing are most likely to be located. Ductwork takes up the greatest amount of in-wall space. It usually consists of plastic flex or sheet metal for all supply air ducts. Return air may run in ducts or partitioned off areas of the wall or floor. You may be able to take advantage of duct space for running wires between floors. In homes that have a flat roof and no crawl space, ductwork is usually accommodated in a drop ceiling or chase such as this, where the ductwork runs the entire length of the house, feeding rooms off of each side. Now, this is really handy because it provides a space for you to run your wiring and also gain access to these rooms. We'll see an example of this in part 3. Next comes the plumbing, including waste lines, drain vents, hot and cold water lines, and gas lines. Waste lines are either plastic or metal, usually 3 inches in diameter, and of course they always run downhill. All the waste lines are connected to air vent pipes, 2 inches or larger, that run to the roof. Now, these are always in the wall above a bathroom or kitchen areas. It's also common for walls with drain or vent lines to be framed using 2x6s, a giveaway that the wall contains plumbing. Now, the water supply lines are almost always 1/2 to 3/4 inch copper. In older homes, they might be iron or steel, and in very new homes, however, they may be plastic tubing. That's a major hazard. Now, it's always good before starting a job to familiarize yourself with the plumbing layout. Now, you can usually figure out the location of the major drain lines and even vent lines by knowing what plumbing or even air vents are in the floor above and where these come out in the basement or the crawl space. Now, if you have any experience with new construction, you should already be familiar with where electrical wiring is usually placed. The area of most concern is near the distribution panel, where a lot of wiring is concentrated. Now, you want to make sure you know where the distribution panel is located and how the majority of the cables are routed through the house by checking in the attic and in the crawl space or basement. About the time houses shifted to platform construction, non-metallic PVC insulated wiring, commonly referred to as NM or Romex, became the standard for electrical wiring. But in balloon frame houses, depending on when they were built, you'll find a variety of other wiring types, including BX. Now, BX is a flexible metal conduit with individual wires inside. And most troublesome, you may also find this knob and tube wiring. Now here, individual cloth-covered wires were run to switches and outlets. The wires use ceramic tube insulators through flooring and wall studs, and it used ceramic standoffs in attics and basements. Now, over time, this cloth has rotted away, and so a lot of this wiring is now exposed in the walls. Now, this can pose a real hazard if your drill bit comes in contact with an exposed wire, so be very careful with this type of wiring. The point of this review of how houses are constructed and what's in the walls is to help you develop an installation plan for any house. Now, your plan will include a careful review of how the house is constructed, determining which walls, floors, and partitions that you can and can't use, determining the location of outlets and devices, and the distribution equipment, and developing a strategy of how to run wires and cables for the easiest installation, and developing a wire schedule. After determining the house construction, the next step is to determine the location of outlets, keypads, and other peripheral devices. The process is nearly the same as for new construction. The challenge is determining whether or not you can get a wire to the outlet location. What kind of electrical and plumbing is in the wall? Where are the fire blocks or other obstructions? And how does the wall connect to ceiling and floors? The next step is to determine exactly where distribution equipment or panels should be installed. The considerations here are almost the same as for new construction. You want this to be a central location that's easy to get to for both you and the homeowner. And also consider how you can use or create vertical or horizontal chases from the distribution location. Remember, the first rule of a professional retrofit is don't overcommit. Don't let the homeowner talk you into attempting to run cable to an impossible location. Don't hesitate to suggest locating an outlet on another wall if you know it'll be a better installation.